Welcome to using the Laplace transform to solve an IVP. So again, the general idea is we can use the Laplace transform to convert an IVP into an algebra problem then we can solve, we can solve for the Laplace transform of our solution y of t. And then we can take the inverse Laplace transform to find y of t. So this will be extremely algebra heavy. Even having just an e to the 2t as your sort of forcing function, you will wind up having to do a fair amount of partial fractions to solve. But we'll go ahead and work through. So let's go ahead and solve the following IVP using the Laplace transform, where the IVP is y double prime plus 4y prime plus 3y equals e to the 2t. With initial conditions, y of 0 equals -1 and y prime of 0 equals 2. So if we set capital Y of S to be the Laplace transform of y of t, then we have the Laplace transform of y prime of t. So Laplace transform of y prime of t would be equal to S times the Laplace transform of y of t minus y of 0. So we wind up getting S times capital Y of S minus y of 0. So we get minus -1 or plus 1. The Laplace transform of y double prime of t is equal to S squared times the Laplace transform of y of t minus S times y of 0 minus y prime of 0. So plugging in those initial conditions and replacing the Laplace transform of y of t with that capital Y of S, we are looking at S squared times capital Y of S minus S times -1 minus 2. Or in other words, S squared times Y of S plus S minus 2. So we now have the Laplace transform of y prime, and y double prime, all in terms of this capital Y of S. So now we can go ahead and take the Laplace transform of our differential equation. So let's take the Laplace transform of y double prime plus 4y prime plus 3y equals e to the 2t. Let me make sure I copied that correctly. With y of 0 is -1 and y prime of 0 is 2. We would be looking at the Laplace transform of y double prime plus 4 times the Laplace transform of y prime plus 3 times the Laplace transform of y. And that should be equal to the Laplace transform of e to the 2t. As we just found, the Laplace transform of y double prime is s squared times capital Y plus s minus 2. So that's our first substitution. Then we have plus 4 times the Laplace transform of y prime was s times capital Y plus 1. So we're looking at 4 times s times capital Y plus 1. Then we are adding on 3 times the Laplace transform of y, which is just capital Y. And then this should all equal the Laplace transform of e to the 2t. That's an e to the at. That just goes to 1 over s minus a. And we have 1 over s minus 2. So again, here we used the fact that the Laplace transform of e to the at is equal to 1 over s minus a. And we use the fact that a was equal to t here. So at this point, we can solve for y. So if we rearrange this, we have an s squared times y, a plus 4s times y, and a plus 3 times y. So we have s squared plus 4s plus 3, all multiplying y. Then we have plus s minus 2 plus 4. And then that should all equal 1 over s minus 2. So this becomes s squared plus 4s plus 3 multiplying y. And then this is equal to 1 over s minus 2 minus s. And that would be minus 2, since negative 2 plus 4 is positive 2, and then subtract it to the other side. Note, the thing multiplying by y is just our characteristic equation, so you can kind of check you did your algebra correctly. And we wind up getting that capital Y of s should be equal to 1 over s minus 2 times s squared plus 4s plus 3, all in the denominator. And then plus negative s minus 2 all over s squared plus 4s plus 3. We can rewrite these right-hand side as 1 over s minus 2 times s plus 3 times s plus 1. And then plus a negative s minus 2 over s plus 3 times s plus 1. So this was rearranging and solving for y. At this point, now we need to, if we can take the Laplace transform, sorry, the inverse Laplace transform, we can take ourselves back to the solution. So now we need to take the inverse Laplace transform. So we'll find y of t, our solution, which will be equal to the inverse Laplace transform of capital Y of s. Again, capital Y was just the Laplace transform of y of t. So the inverse Laplace transform of capital Y should take us back to y of t. So we're going to need to do some partial fractions. So 1 over s minus 2 times s plus 3 times s plus 1. We should be able to write as a over s minus 2 plus b over s plus 3 plus c over s plus 1 There are tricks you can apply that don't require multiplying through. I find it sort of too easy to get tripped up and lose track of what I'm doing. So I'm going to continue multiplying through by the denominator. So we would have 1 is equal to a times s plus 3 times s plus 1 plus b times s minus 2 times s plus 1 plus c times s minus 2 times s plus 3. This is convenient as long as you have just a series of linear factors. We'll just plug in values that make things equal to 0. So if we plug in s equals 2, then that will make the second and third terms equal to 0. And so we just have 1 is equal to a times 5 times 3. And then the rest would be 0. And so we wind up getting that 1 is equal to 15 times a, or a is 1/15. Now let's go ahead and work on the next one. Let's plug in s equals -3. So I'm just plugging in the roots of our denominator and getting the various terms to cancel out. So in this case, everything cancels out except that middle term. So we would have 1 is equal to b times -3 minus 2 is -5. And then -3 plus 1, we're looking at -2. So we got 1 is equal to 10b, or b is 1/10. And then for our last term, we're looking at c over s plus 1. So let's plug in an s equals -1. This becomes 1 is equal to c times, we should have an s minus 2 times an s plus 3. So we have -1 minus 2 is -3. And then s plus 3, -1 plus 3 is a +2. So we get 1 is equal to -6 times c, where c is equal to -1/6. So what we have figured out so far is that 1 over s minus 2 times s plus 3 times s plus 1 is equal to 1 over 15 times 1 over s minus 2 plus 1/10 times 1 over s plus 3 minus 1/6 times 1 over s plus 1. That was just the first fraction from our right-hand side. So we've done the first component of our y of s. Now we need to do the -s minus 2 over s plus 3 times s plus 1. So our next piece, we have -s minus 2 over s plus 3 times s plus 1. This should be able to be written as an a over s plus 3 plus b over s plus 1. So we are looking at -s minus 2 is equal to a times s plus 1 plus b times s plus 3. If we set s equal to -3, then we are looking at -3 is +3 minus 2 is 1. is equal to a times -2. And so we get that a is -1/2. If we set s equal to -1, negative s would be -1 or 1, -2 would be -1, and that is equal to b times s plus 3. -1 plus 3 is 2. And again, we get that b is -1/2. So if we just check that, -1/2 times s plus 1, we'd have a -1/2 s minus 1/2. And then a -1/2 times s plus 3, we would have a -1/2 s minus 3/2. And that does add together to give us -s minus 2. So what we get then is that this -s minus 2 over s plus 3 times s plus 1 is equal to -1/2 times 1 over s plus 3 minus 1/2 times 1 over s plus 1. Now, clearly, we could have done this in a slightly different form if you want. So if you wanted to, we could have, at the stage where we had y of x equal to the sum of two fractions, we could have just gone ahead and combined those two fractions if we wanted to, and done partial fractions just on one by giving those a common denominator and combining them, or we can work with the two separate ones and do two separate partial fractions. It is completely up to you what you would like to do, but you're welcome to give your things a common denominator and then do partial fractions from there if you don't want to have to do multiple sets of partial fractions. All right, so at this point, what we have is we have the capital Y of S is equal to, we had 1/15 times 1 over s minus 2 plus 1/10 times 1 over s plus 3 minus 1/6 times 1 over s plus 1. And then we have minus 1/2 times 1 over s plus 3 minus 1/2 times 1 over s plus 1. Let me update my screen. So here I just put everything we found all together. We can combine these if we want. So this is 1 over 15 times 1 over s minus 2 plus 1/10 minus 1/2 times that 1 over s plus 3 would be minus 4/10 or minus 2/5 times 1 over s plus 3, and then minus 1/6 minus 1/2, we would be looking at negative 4/6 or negative 2/3 times 1 over s plus 1. And our final step is to now find y of t, which is the inverse Laplace transform, again, of y of x. So we're just finishing off what we've been working on. We've got it now into the proper form. Sorry about that. We've gotten our situation into the proper form. So we have y of t. Sorry, I'm going to rewrite y of s one more time, this time using Laplace transform. So capital Y of s is equal to 1/15 times the Laplace transform of e to the 2t minus 2/5 times the Laplace transform of e to the negative 3t minus 2/3 times the Laplace transform of e to the negative t. And so we get that our y of t, which is just the inverse Laplace transform of y of s, is 1/15 times e to the 2t minus 2/5 times e to the negative 3t minus 2/3 times e to the negative t. So in this process, we have found our particular solution and we have solved for C1, C2. All of that work is done for us through the algebra once we've taken the Laplace transform. It's not the most pleasant work to solve these problems, as you can see. Manipulating our sort of y of s into a format where we can take the inverse Laplace transform can be annoying. But this is another technique we have for solving IVPs.